第42集宇宙大爆炸。
Hello, Meng Meng. What are you looking at up there?
我看到了行星、星星，还有银河系，宇宙简直太美了。
I agree. It can be quite inspiring to look at the stars. I wonder if you've had any thoughts come to mind from observing the universe. You know, scientists have asked some pretty big questions and have become inspired to seek the truth when looking up at the universe.
我在想，或许有一天我能飞到天上跟这些星星见面呢。伟大的问题嘛，我也有许多。
So why don't you tell me some of them?
比如，宇宙到底有多大？星星从哪里来？它们一直在天上朝我们眨眼睛吗？
Wow, those are big questions. Scientists think about questions like this as well, such as, did the universe have a beginning and will it have an end? What came before the universe and what will come after? Sometimes we can use scientific theories to answer these questions, such as when the universe had a beginning and what will happen at the end.
哇，我简直太了不起了！我可以当科学家了。但是克里斯博士，科学家们为什么会思考这些问题呢？难道宇宙会在某天消失吗？
Well, if we use our scientific theories to analyze this question, we can say that the universe did have a beginning and will come to an end. Let me give you an example. From the second law of thermodynamics, what happens to entropy?
声会越来越大。我记得那是因为乱糟糟的东西声都很大，而且我发现这种情况总会发生。
That's right. And what about temperature? If two things have different temperature and we bring them together, what will happen to them?
如果把冰扔到水里，它们最终会融化掉，水会比一开始的时候凉。
Yes. The atoms of the ice are frozen in place, and so ice has low entropy. But when the ice melts, the atoms are free to bounce around, and this is higher entropy. So the original ice and water come together and make the same temperature, and this situation has higher entropy.
对，我记得这是热力学第2定律，克里斯博士。热量武士总想从被关注的地方跑出去，可是这个能告诉我们什么有关宇宙的知识呢？
Well, let me ask you this. Which has higher temperature? The sun, the earth, or the moon?
当然是太阳温度高呀！太阳一年四季都是一个大火球，但是地球的冬天可冷了。妈妈告诉我，月亮上也冷，这就是我们为什么管嫦娥在月亮上住的地方叫广寒宫。
Well, then you know that the universe contains lots of things at different temperatures, right?
对，因为温度不同，从太阳来的热能武士一定会想方设法跑向月球。那然后呢？
You still don't have it? What about you, children? Do you know what the second law of thermodynamics says about the universe? It's okay if you don't. It's quite deep knowledge. But I will show you today. Come with me. Hello, children. Today, we will learn what the second law of thermodynamics tells us about the fate of the universe.
告诉我们吧，克里斯博士。
Okay, so let's recall what we know. We know that the temperature of two things will come to be the same. And we know that there are lots of things in the universe at different temperatures. So, what will happen to them?
你是说宇宙就像一杯水，所有的事物都会变成一样的温度？
Yes, the universe is like a basin of water. And based on the second law of thermodynamics, what will happen to the entropy of this water?
熵会增加。
That's correct. Do you remember the experiment we did last time? Our basin of water was the universe, and we had soap bubbles for planets, and food coloring for the stars, and sugar for the comets. There were cold places in the universe, the ice, and warm places in the universe, the kettle water. And what happened to them? What happened to everything?
熵增加了，它们都消失了，所以事物都混合到了一起，最后变成一个样了。
Good. Well, not good actually. It's quite disturbing.
难道我们的宇宙也会变得跟实验结果一样吗？
Yes. It means that everything in the universe eventually will end up as unusable heat energy. Everything will be the same temperature, everything will look the same. It will be like a perfect mixture, just like our basin of water.
啊，我不明白，那就没有发热的太阳和能生存的凉爽的星球了，所有的星球都是一个温度。
No, there will be no planets, no stars, no people, just emptiness.
什么？克里斯博士，你是在吓唬我们吗？
It's a scary thought, I warned you. But you don't need to worry that much. The universe won't end for a long, long, long time.
哦，还好，现在还是给我们讲讲不吓人的东西吧。
Okay, how about I tell you about the birth of the universe? It's much more exciting. It's called the Big Bang. Children, let's think about moving backward in time. If entropy increases when time moves forward, what happens to entropy as time moves backwards?
肯定会减少、降低呀，就像是看一部倒着放的电影一样，所有的脏乱都会被清理干净。
That's right. Do you remember when we watched the video of the food coloring played in reverse? Doesn't that look strange? We don't expect entropy to decrease all by itself.
这看起来的确挺奇怪的。我知道现实中食用色素是不可能往回聚集的，但是你为什么要让我们观察这个呢？
Well, we know that entropy must always increase. But if we make time go in reverse, we can infer the original appearance of things.
哦，我明白了。所以如果我们将时间倒转，熵就会减少。那它还会不会停下来呢？
Well, if we use numbers, what happens to a number that keeps getting smaller?
它会一直减少，再减少，直到变成0，对吗？
Yes, exactly. And we can use this principle to infer the beginning of the universe. One way for the entropy to be close to 0 is to have all the stuff in the universe in one little spot. Maybe this reminds you of some red food coloring that you've seen?
哦，对，水里的食用色素，当食用色素都集中在一个地方的时候，就是低熵。你的意思是说，宇宙中的所有事物都和食用色素刚滴入水中的状态是一样的？
Yes, and it spread out very quickly. Scientists call this the Big Bang.
哇，宇宙的开始是因为一个大爆炸吗？
A Big Bang, almost 15 billion years ago. And the entropy has been increasing ever since. The universe has made quite a mess, but it's a beautiful mess of stars and planets and galaxies. And we know all this because of physics.
因为统计物理学，对吗，克里斯博士？
That's right, Meng Meng. And now you know statistical physics. And by the way, have you cleaned your room lately?
你走进我的房间，看满地玩具照片，为何不收拾整齐？尘土覆盖风卷边，夜色我仰望流星，想追问一切起源。到底银河有了开始？会不会走向终点？只因为一次释放，世界走到了今天。 那就是宇宙大爆炸。混沌初开天地线，这就是万物宿命。混乱是命中注定，但你却一直在努力，让混乱重归有序。我说的不是游戏，是物理学的经典。加入宝宝的物理学，带你看上的变迁。